Welcome to The Explainer. Today, we're diving deep into the engine of our mind to figure out what really powers one of the most fundamental human drives, curiosity. And we're going to start with a question that I think we can all relate to.
Think about it. It's something we all do without even thinking. But that simple, quick turn of the head, it's way more than just a reflex. It's actually a little window into the most ancient, hardwired part of our brain, and its relentless, unending quest for new information. So to really understand curiosity, we have to start right there, with that initial head turn. It's like this involuntary alarm system, and it's where that very first spark of inquiry is ignited. Now this, what's that reflex? It's not a choice. It's a really ancient program, so fundamental that even fish have it. And its main job, its only job, is to force us to gather data about any sudden change happening around us. So how does this alarm system actually work? Well, it's surprisingly elegant, and it all comes down to a really simple circuit. Just imagine a constant, steady sound in the background. A signal for that sound arrives at a neuron, but it's immediately followed by a delayed opposing signal. They perfectly cancel each other out, and the system stays quiet, in balance. But what happens when a new sound pops up, or that old one suddenly gets louder? The first signal, the positive one, gets stronger instantly, but the cancel copy? It's on a delay. So for just a split second, that new, strong signal completely overpowers the old, weaker cancel signal. And that imbalance? That's the alarm. It screams at your body, hey, something's different, look now. And just like that, you turn your head. So what's our reward for obeying that reflex? What do we get out of it? Well, we get a nice little flood of one crucial chemical, dopamine. That small hit of pleasure we feel. That's the pure joy of discovering something new. But that initial dopamine hit doesn't just make us feel good. It pushes us to do more. See, just looking at something new isn't enough. Our brain is actually compelled to do more than just see the unknown. It wants to physically get in there and engage with it. You can think of this drive to act as a kind of ladder. It starts on the bottom rung with the midbrain's simple glance. Then the subthalamus kicks in, and that drives us to actually move towards the new thing. And finally, the motor cortex takes over for some real hands-on investigation. This whole drive to explore, it's really all about preparing for the future. I mean, think about that cat. It's not necessarily hungry or scared. It's gathering data. It's building a mental map so it knows where to find food, where the escape routes are, or where the safe hiding spots are for later. Its brain is basically saying, nope, can't rest, not until I have a complete map of this entire place. But here's the catch, right? Exploration is always risky, and that sets up this constant tug-of-war inside the brain. You have the drive for new information pulling you forward, while the instinct for self-preservation, for fear, is holding you back. It's this fundamental conflict. Should I learn more, or should I just stay safe? And you can see this dynamic play out perfectly in lab experiments. A rat is placed in a maze that has some safe, dark arms and some risky, open, brightly lit arms. The rat's first instinct is to hide in the dark. But, after a few moments, it just gets bored. That drive for something new becomes too strong, and eventually it'll cautiously start to venture out into the light, trying to balance its need for safety with its powerful curiosity to explore. So these first levels of curiosity, looking, exploring, manipulating, we share those with a lot of animals. But now we're climbing to the top level. And this one is a uniquely human superpower. This is where language changes everything. A child first learns to connect the sound bunny with a specific stuffed animal. Simple enough. Then their brain does something amazing called visual generalization. It learns that all these different looking things, a plush one, a cartoon, even one made of chocolate, all share the core features of bunny. But then comes the real magic, verbal generalization. The brain creates a totally new abstract category called toys that holds the concept of bunny and so many others. And after doing this over and over and over again, we build something absolutely extraordinary in our minds, an information model of the world. Now, it's not the world itself, but it's a simplified, incredibly powerful internal simulation of reality, a map of not just things, but of all the relationships and categories that connect them. Having this internal model is what lets us do everything we think of as unique human. We can run simulations of the future to make plans. We can find surprising connections between ideas, which is really the basis for all creativity and humor. We can even build entirely new models from scratch, which is the foundation of all art, invention, and storytelling. It's incredible.
Okay, so here's the big question. If our brains are these amazing novelty-seeking machines, why do we so often get stuck in a rut? Why do we prefer the same old thing to something new? Well, it turns out our powerful curiosity has two great enemies. First up, there's habituation. That dopamine hit we get from a new experience gets smaller and smaller with each repetition. It's kind of like the travel agent syndrome. The 100th trip to that tropical paradise just isn't as thrilling as the first. And second, there's stereotyping. Our brain is fundamentally efficient. It loves to save energy by creating familiar routines and then just sticking to them. The known path is always the easiest one to take. And this creates a really critical challenge for us, especially as we get older. The brain's default setting is to just settle into these comfortable, easy patterns. So to stay curious, to keep learning and growing, we have to actively fight against this energy-saving impulse. It takes real, conscious effort. And the stakes here are pretty high. When we stop feeding our brain new experiences, the very dopamine system that powers our motivation and our joy can start to run dry. And that's really the root of burnout, a life that feels totally predictable, but also completely empty.
So here's the thought I want to leave you with. Your brain isn't built for a predictable world. It is an exploration engine designed from the ground up to delight in the new. So the next time you feel that little pull to learn something, to explore a new place, or to just ask why, remember, you're not just killing time, you're fueling the very engine that makes you human.